Hello everyone, today we'll talk about the solution to the problem final prices with a special discount in a shop. The central thing that we should notice to solve this problem optimally is that at any point when we're running the algorithm, we've seen some items from the left, and for some of them we already know the discount. Those are the items for which we have seen the item, and then we've also seen an item that's smaller than that item. In that case we know the discount and we already know the result. However, for some items, we don't know the result yet. And what does it mean for us not to know that result? Well, it means that there was no element that was smaller than that element to the right of it. That means that the list of elements for which we do not have the result at this point is increasing. It's obvious that it's increasing because if it wasn't increasing when they are ordered by their index, then that means that there is some situation where we have an value for which we don't know the result and another value for which we don't know the result, which is smaller than that value for which we don't know the result earlier, which means that it could be the discount for the left value. So it's impossible for us to have a situation like this, so the list will be just simply increasing. And that means that we can maintain all the elements for which we do not yet have the discount, and whenever we have a new element, then that element will be the discounting element for those elements we have that are greater than it or equal. So we'll be removing them from the end of our list. We can look at our list as if it's a stack. And then we have to append our element because we don't know what the discount for that element will be. So the algorithm looks like this. We have our stack, which is just implemented as a list because we want to push and pop to the right end of the list. We look for every value in our list of prices. So v is value, I is the index because we'll be maintaining indices in our list of options because we want to update the final price. So you have to remember the index, not just the value. And now while there is something for which we do not know the discount, and we can discount it using v, that means that v is the first value with which we can discount this last element in options. So we discount it. We take that element from the list of options, we subtract v, and that's it. We now have one fewer element. And at the end we append our index to the stack, and that means that the values again are increasing because everything that was bigger than this value from the stack that was already increasing was removed in the previous step in this while loop. And at the end, of course, we just return prices.